this lesson we are going to talk about derivatives. So a derivative of a function, let us say that we have a function y equal to f of x, and we would like to find the derivative. So firstly, finding the derivative of this function using limits. Okay, so then let us say that again we write down this function y equal to f of x. If there is a small change in x, small change in x, call it delta x. So this change is either positive or negative, so that means x becomes x plus delta x. Right, then this will be followed by change in y. So x, if x changes, then y would also change, right? So followed by change in y. So that means, we call this change in y, we call it, so call it delta y, right? So meaning that we can write this function as follows. So previously we have y, so that was equal to f of x, right? So and then if there is a change in x, if x increases or decreases by small amount delta x, then y would also change. So then that means y would become y plus delta y. So and now we can write this, so we can take y to the right hand side, and then we will get delta y would become f of x plus delta x minus y, and that is equal to, then we can write it again, we say delta y would be f of x plus delta x minus y. Y in this case is f of x, because y is basically equal to f of x. So if we divide both sides by delta x, and we divide also this side by delta x, and then taking the limit, so we can take the limit of both sides. So now we take the limit as delta x approaches 0. So that means we have very small change, right? So now we take the limit of both sides. So what we will have, we would say that limit when delta x approaches 0, delta y divided by delta x will be equal to limit f of x plus delta x minus f of x divided by delta x as delta x approaches 0. So basically this is the rate of change. Delta y divided by delta x, this represents the rate of change. And you find it in the books. So if y changes from y1 to y2 and x changes from x1 to x2, then the rate of change will be equal to y2 minus, or both correct, y1 minus y2 divided by x1 minus x2, or you can also say y2 minus y1 divided by x2 minus x1. So, and now the limit is denoted by, so this is now the derivative. So the derivative is approximately the limit of delta y divided by delta x when delta x approaches 0. So now this is our derivative. So the formal definition of derivative, and of course this is equal to limit f of x plus delta x minus f of x divided by delta x when delta x approaches 0. So now this is a formal definition of the derivative using the limit. So now we can take one example. So this is just a simple example. Let us assume that we have y equal to x squared. So you already know that from your lessons at school. You know the derivative dy by dx is equal to 2x. Now we would like to find the derivative but using the limits. So we still did not introduce the direct rule of finding a derivative. So in this case, again, if you want to solve this, or if you want to find, so the question says consider, so this is find dy by dx considering this function. So again we follow the same way. So we can directly substitute here in the limit, or we can simply follow the same way. So we say that if there is a change in x by delta x, then that will be followed by also a change in y by delta y. So that means x will be replaced by the x plus delta x. So because the new x, the old variable was x, but now we are dealing with x plus delta x because we are assuming that there is a small change in x by delta x. So now again we can write it as follows using the similar idea: plus x plus delta x squared minus y. And we already know y, so we say delta y, that will be x plus delta x squared minus y. Y is given here, which is x squared. So now we can divide both sides by delta x, and also we can divide this side by delta x. So, and to find the derivative, we say the derivative of this function is by taking the limit as delta x approaches 0. So for the rate of change, dy by dx, and that would be equal to limit x plus delta x squared minus x squared all divided by delta x when delta x goes to 0. So again, we can simply expand this x plus delta x. I mean, there are many ways you can find the limit. Of course, we can add x here and subtract x from there, then we can also find the limit. But now let us keep it simple because the exponent here is only 2. So we can say limit. If we expand this, we get x squared plus 2x delta x plus delta x squared. Here that is delta x squared. So then we divide everything by delta x, right? Then we take in the limit here. Sorry, we have again minus x squared. Don't forget it. So then as delta x goes 0. So now we can, the x squared will cancel out because we have a positive x squared and we have a negative x squared. And then we can also do the following. So now we have, dy by dx, that is equal to limit. After doing this cancellation, we get the following. So we would have 2x delta x plus delta x squared all divided by delta x. So now we can distribute the denominator. So then we will get limit as delta x approaches 0. So we would have here inside those brackets, we will have 2x delta x divided by delta x, and then plus delta x squared divided by delta x. So, and now those will also could also cancel out, and then here the square 1 delta x would go with 1 delta x in the denominator, and then this will be limit 2x plus delta x as delta x approaches 0, right? So now we look at the first term, we don't have delta x, so that means we don't care about this term. That is not 0. I mean that we don't have delta x, there is nothing to substitute, then it's just like a constant in the limit. Of course it is not a constant, but then usually we treat it as a limit, so sorry, as a constant in this case. But now only we substitute delta x here is equal to 0. That means that will be equal to 2x plus 0, which is equal to 2x. So this is the final answer. Now finally we need to write it very clear, and we said dy by dx is equal to 2x, and this is what we would like to find. So this is the final answer.